We want to learn about analyzing and displaying data, the results of experiments. And at the end of the class, you should be able to calculate the mean, which is a measure of average, calculate the standard deviation, and use IT, specifically Excel, to do the same calculations, work out the mean and standard deviation, and also to present information in a variety of graphical forms, such as bar and pie charts. Often you need to perform calculations on raw data in order to get the results from which you will generate a conclusion. So you have to analyze it and then display it. The two most common ways of analyzing it are calculating the mean and calculating the standard deviation. The mean shows you the average, and the standard deviation how far the data spreads away from the average. Excel can calculate both of these using the average and standard deviation functions. For example, equals average B5 to B11 will calculate the average of the data in cells B5 to B11, or equals standard deviation C5 to C11 will calculate the standard deviation of the data in cells C5 to C11. But you should be able to calculate them too. To calculate the average or mean, find the midpoint of each data group, multiply the midpoint by frequency, and find the total of these values and divide by the total frequency. The formula mean is the sum of midpoint times frequency over the sum of frequency. It's much easier to understand this by an example. So here's a set of data where we're saying some measurements were taken, and between 1 to 5 seconds there were 6 events, there were 5 events 6 to 10 seconds, 4 events 11 to 15, 2 events 16 to 20, and 3 events 21 to 25 seconds. The midpoint of the class then is 3, 8, 13, 18, 23. Frequency times midpoint. You can see here. So we're going to add all these up, and we're going to add all these up, and then our mean is this figure divided by this figure, which in this case is 10.75. The standard deviation, how much the data deviates from the mean, denoted by the Greek letter sigma. Sigma equals the square root of the sum of f frequency upon x minus x bar squared. That's the midpoint of the class, take away the mean, squared over the sum of f. Again, best seen through an example. Again, you make out a table. There's your data that you start with. Midpoints 3, 8, 13, 18, 23. F times x. As you see, this is enough to calculate the mean. Mean of 10.75. We've already calculated that. You fill out this column then. Midpoint minus the mean. Square this column. And then multiply this column by frequency f. We want to sum this column then, add them all together. Sum this column, add them all together. And then sigma is the square root of the column in the extreme right divided by the frequency column, which in this case equals the square root of 973.7 divided by 20, square root of 48.69 or 6.98. Another example, temperature, frequency, midpoint, f times x. That's enough to work out the mean. Add these, gives you 603. Add these, gives you 30. Mean then 603 divided by 30, 20.1. That'll go in here. Midpoint minus the mean. Square this column. Multiply by f. Add it up. And then your sigma is sum of this column divided by the sum of this column. In this case 2.70. Try it for yourself. There's another couple of questions. How to go with them yourself. Now, when you've calculated your data, calculated your average, calculated your standard deviation, sometimes you want to display the information. A simple way of doing that is in a bar chart. Bar charts are particularly useful where you have a number of things to display. Entertainment, budget, expenses, all together under that one subheading, entertainment. Budget, expenses, saving, books, saving, groceries, budget, expenses, etc. Pie charts are useful where you want to split up a total into its different constituent parts. So here you might want to split up the budget into the different things the budget is allocated against. And there you can, it's very easy then to see visually what are the big winners in the budget and what are the big losers. Histogram, another type of chart, good for showing data where you have classes like this, a frequency distribution. This time repeat example 8.3 using Excel to get the answers to the mean, standard deviation, and draw the histogram. So we learned today the purpose of a distribution is to display data in a visual form. Formula for frequency density, we'll not worry about. We can calculate the mean, we can calculate the standard deviation, we can do them manually, we can do them using a spreadsheet, and we can use the various charts available in Excel to display data.